Okay, so let's jump into this video and talk about our closed loop O2 control and our deceleration fuel cut and what we can do when we're doing our tuning and programming to make sure they're not going to have an overlapping effect and create drivability problems. Now, when we're working with an OEM ECU, this is not going to be a factor. So if we're working with a Honda, GM, a Ford ECU, we don't have to worry about this. The OEM engineers have taken this into account and they're going to be blocking it out from happening. Now, in a standalone ECU, Motec, Haltech, AEM, they're going to have the ability to actually have this programming capability so they have overlapping, which can create problems, which is where we need to pay attention. So if you're on a standalone ECU, this is going to be something you have to factor in while you're doing your tuning process. I'm going to be showing you two different techniques that we can ensure that this is not going to be an issue. Now, very quickly, taking a look at the deceleration fuel cut, it's going to be where we actually shut off the fuel injector when we're in lift throttle conditions. Some standalone systems will be calling it overrun fuel cut. Some will call it deceleration fuel cut, essentially the same thing. And we'll find that the engine can run on momentum alone. So as it's going and coming down and decelerating down into actual idle speed, it can run based on just that reciprocating mass spinning the engine around. And once we get closer to idle, we turn the fuel injector back on, we get stable combustion, it's going to go right back into idle, and it's going to have maintain our idle, catch our idle, and we're not going to have any issues. Now, when we're talking about our closed loop O2 control, we're going to be looking at the actual O2 sensor reading, compare it against an actual target reading. We have a target air fuel table, and it's going to be making adjustments to the main fuel table, maybe 5 or 10% adjustments as you're driving around, so you have consistent air fuel at all operating conditions. So there is a possibility when we're in lift throttle where we can have the closed loop O2 control taking a look at the lean condition. So the deceleration fuel cut kicks in when we lift our throttle. It's going to go full lean because we don't have our injectors on. And the closed loop O2 control, if it's left to be able to trim the mixture, it's going to see that it has a lean condition, lean air fuel. It's going to wind up the calculations and add 10 or 15 or 20%, and whatever that maximum amount we're allowing it to add is. Once we come back on the throttle, it's going to immediately apply that overly rich correction to our fuel table. It's going to be an artificial rich correction. It's not going to actually be that lean. We know that the injector's off and we don't need to do any actual corrections. So when we come back on the throttle, it'll run really rich for a split second until it realizes that it's too rich. Then it's going to go the other way and try to pull the fuel out, and then it actually can have some oscillation effect as you're coming on and off the throttle. It can be trying to trim itself and chasing the adding and subtracting of the fuel against that target value. So it's going to be something that creates drivability problems, unstable problems, oscillation problems, all things we want to avoid. So I'm going to show you the two techniques that I use to make sure that I don't have this happen. Either is going to be a valid way to go and fix this and not have it happen. It's just going to be really a matter of personal preference of which one you decide to use in your process. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.